But when x is 10, when x equals 10, the expressions are equal. Like this is a true statement. 57 does equal 57. Down here, 27 is not true. 27 does not equal 21. That is not a true statement. When x equals 10, expressions are equal. Therefore, x equals 10 is the solution. Okay. So that's one really important thing to understand about math is what the solution means and how you can tell if your answer is right. So we're also going to learn in 219 about some other things. So I'm going to look at this equation here. This equation is going to turn out slightly differently. Sometimes you are going to see equations like this. We're going to go through all of the same simplifying steps. 2x plus negative 4. I'm going to do keep, change first and change all of my subtraction into adding negatives. So I change this subtraction and this subtraction. Then I'm going to go through and I am going to combine like terms. So 2x plus negative 4x is going to equal negative 2x. And then on the other side, I can combine 3x plus negative 5, and that is also negative 2x. And then I can also combine 9 plus negative 2. 9 plus negative 2 is just like saying 9 minus 2, which is 7. Okay, and then there's no other like terms to combine, so I'm going to rewrite this like this. So negative 2x plus 7 equals negative 2x plus 7. I'm noticing right now that those are the exact same thing, and that's actually going to be important. But I'm going to continue simplifying for a minute. Let's do some removing balance sets. I'm going to take 7 away from both sides, minus 7, and that is going to give me negative 2x plus 0 instead of negative 2x. So it's going to be negative 2x plus 0. And then on the other side, it's going to be negative 2x and also plus 0. And as I continue to go, I'm going to subtract 2x. I'm going to subtract negative 2x from both sides. So now I'm going to go, actually the way I'm going to do it is I'm just going to add 2x to both sides to 0. To get rid of these x's here, I'm going to add 2x, and that's going to become 0x. And then over here, I have to add the same amount, and so that's going to become 0x. And so now what I have is 0 plus 0. The whole thing is equal. So 2x, negative 2x is equal to 0, and when I take those away, 0x is equal to 0x. The whole thing is just 0 equals 0. So, because 0x equals 0. So in every single one of these steps, I notice that I'm just getting the same thing on both sides. And that actually means something very, specific. So when you see an equation where you have the exact same expression on either side, whether it's 0x and 0x, 0 and 0, negative 2x plus 0, right? Negative 2x equals negative 2x, or negative 2x plus 7 equals negative 2x plus 7. When you see that everything is the exact same, there can't be any other parts. It just has to be that this part is everything is the exact same. That what this means is, let's see, we're gonna write it right here. When both expressions in an equation are identical, So when you see that, it means that like any number could be true. Like if x was equal to 1 here, then negative 2x plus 1 is going to still equal, the x has to be 1 over here too, so it's still going to equal negative 2x plus, negative 2x plus 7 is going to equal negative 2x plus 7. So negative 2 times 1 plus 7 would be negative 2 times 1 is negative 2, plus 7 is 5, and that's going to equal 5 over here. If x was 10, negative 2 times 10 is negative 20, plus 7 is negative 13. And then over here, negative 2 times 10 is negative 20, plus 7 is 13. So 13 does equal 13. So when you see stuff like this, x could be like any number. Negative 2 times 100 plus 7 equals negative 2 times 100 plus 7. So when you see that it's the same thing, that you're just saying this is equal to the exact same thing on the other side, x could be anything. It doesn't matter how big or how small x is because it's the exact same on both sides. And so what we say for that, instead of writing down x could be 1 or 2 or 3 or 4 or 5 and just continuing to go, what we do is we say when both expressions are in an equal, when both expressions in an equation are identical, we know that all numbers are solutions. So this is actually what you write. You actually write all numbers are solutions as your answer. All numbers are solutions. Because all values for x will make this a statement true. Any number will make this a true statement. It's always a true statement. Okay, now we're going to look at this last one. So on this last equation, we're going to look at it and we're going to, again, think about the simplifying steps. My favorite one to do first is to change all subtraction to adding negatives. And then after that, we're going to combine like terms. It's getting a little bit crowded over here, so I'm going to try to bring this over. I noticed that 1x plus 3x is equal to 4x. And then I still have plus negative 5 on this side, but there's no more like terms to combine over here. And then on the other side, there's no terms to combine at all and no keep, change, change. So I'm just going to leave this as 4x plus 7. And then my next move is going to be, let's see, I'm going to remove a balance set. It doesn't really matter which one I do. I am going to start with, I'm gonna add 5. I want to get rid of this negative 5, so I'm going to subtract negative 5. And then I'm going to subtract negative 5 over here as well to stay balanced. And when I'm done with that, well, let's see. To calculate that, I'm going to remember that I can change minus negative to adding positive. And I am going to say, okay, so 4x plus 0. This has just become plus 0 because negative 5 plus 5 is 0. And on the other side, it's going to be equals 4x plus 12. 7 plus 5 is 12. So I still have the 4x, but now I have plus 12. Okay, so let's see. These, I still haven't simplified these all the way yet. I'm going to keep going. I'm going to simplify by removing, I'm going to subtract 4x next, minus 4x, minus 4x. And now I have 0, right? I have 0 plus 0 on one side. Right, this is 0 plus 0, which we know what that equals. And then negative 4x minus 4x over here, we have 0 plus 12. Now, is this a true statement? We need to look at this. When I'm looking at this, I know that 0 plus 0 equals 0, and 0 plus 12 equals 12. So what do we notice about this? I have just solved the equation, and it's not true. Like, there's no true statement here. So I think what I what I need to point out now is that, sorry, I needed to look at what colors I used for the other notes. So this equation is just not like I'm just looking at something that I know is false, right? 0 does not equal 12. And so when you see that, I could actually see that up here too. 4x, it doesn't matter what x is here. There is no value that if I multiply it by 4, I will get the same answer as if I multiply it by 4 and add 12 to it, right? If whatever value x is here, when I see that the variables, that's the x's, when the variables match, but the constant numbers, that's the numbers that don't, the constant numbers don't match, there's a very different thing going on here. It's literally not possible for 0 to equal 12. It just doesn't. It doesn't matter what value x is. There is no value that will make 0 equal to 12. There's no value. Whatever number I put here, if x is 100, this becomes 400. This side over here becomes 400 plus 12. 400 does not equal 412. They're not the same. If x is 1, 4 plus negative 5 would be, 4 times 1 would be 4, plus negative 5 is negative 1. And then this one, 4 times 1 is 4, plus 7 is 11. Negative 1 does not equal 11. In no cases are these equal. It doesn't matter what they are. And you can tell by looking. So what that's saying is, the question is, what value for x will make 3x plus 1x plus negative 5 equal to 4x plus 7? And what we're finding when we do this, when you solve it and you come up with something like this, is there is no value for x. So we're going to write that out. The pattern is when, let's see, when all variables match, in an equation, actually, I'm going to rewrite this part. I need to get a smaller eraser here. Okay. We're going to say this differently. When expressions have matching variables, but different constants. Constants are just the regular numbers that you guys have been learning about since kindergarten. But different constants, the equation is impossible. And has no solutions. That's the important part, no solutions. So when you see this, you write no solution. There is no solution for this problem. Remember, the solution is the value that makes the math statement true. And in this case, there is no solution for x that will make 3x plus 1x plus negative 5 equal to 4x plus 7. There isn't one. So there's no solution. All right. So we're going to be working on our next assignment. We're going to be getting lots of practice looking for this. Thank you guys for listening.